Okay, so I've got some crazy news for you. You know how we have this asteroid impact that wiped out the dinosaurs? Well, scientists just found out it may have also triggered the largest volcanic eruption in Earth history. And if that doesn't seem like a big deal to you, just wait until you hear about what's actually inside those volcanoes, because it might just hold the key to understanding why life keeps coming back stronger after major ecological disasters like this one. The story of the Chixulub event is one that you probably learned about in school. About 66 million years ago, our planet collided with a 7-mile-wide asteroid or comet, which caused an extinction event that wiped out the dinosaurs and 75% of all species on Earth. While the impact site is located on the Yucatan Peninsula in Mexico, its effects were felt around the world within days. After the impact, there was a massive release of dust and debris into the atmosphere which blocked out the sun and disrupted climate patterns across the globe. The temperatures dropped, rain became scarce, and photosynthesis slowed down, collapsing the entire food chain and causing mass extinctions. But what's really interesting is that while this asteroid had an immediate impact on life on Earth, it may have also set off a series of events that would cause significant changes over millions of years afterwards. And according to a new study published last month in the journal PNAS, these events were linked to the formation of supervolcanoes, some of the largest volcanic eruptions in the planet's history. You see, when the asteroid slammed into Earth, it didn't just leave a crater behind, it left behind a lot of heat. And I mean a lot. In fact, it's estimated that the energy released by the asteroid impact was equivalent to 40 trillion nuclear bombs. That's an absolutely astronomical amount of energy. To put that into context, if you lit up 40 trillion matches, the light produced would be as bright as the full moon. So imagine the power of 40 trillion nuclear bombs, and you begin to understand the kind of heat that was suddenly dumped into the Earth at the Chixulub site. And here's the thing. That much heat could have potentially melted rock deep beneath the surface, triggering volcanic activity that we're only just discovering today. Now, obviously, we can't observe what was happening directly beneath the surface of the Earth 66 million years ago. So scientists have to rely on indirect evidence to form their hypotheses. But they've been able to do this in other cases, such as the 1883 eruption of Krakatoa in Indonesia. That event released about 200 billion cubic meters of ash into the atmosphere, and scientists were still able to detect magma chambers beneath the surface of the ocean floor using seismic tomography. By sending out sound waves through the ocean floor and measuring how long it took for them to get back, researchers were able to identify magma chambers that were 200 kilometers beneath the surface. So, if a relatively small volcanic eruption like Krakatoa can leave behind this kind of signal, then a cataclysmic event like the asteroid impact should leave behind something much more significant. And that's exactly what researchers found. Using a similar method, scientists have discovered a giant magma chamber beneath the surface of the Caribbean Sea. And according to lead author of the study, Dr. Stephen Grasby, the results suggest that melting related to the asteroid impact extended down 200 kilometers into the Caribbean large igneous province, a region with several hundred volcanoes. Now, you may be wondering, what does melting rock have to do with asteroids? Well, when an asteroid collides with Earth, it doesn't just impact the surface, it causes a shockwave that travels through the planet. This shockwave can melt rock deep beneath the surface. And depending on the composition of the rock, the melted material can either solidify quickly or slowly. In the case of the asteroid impact, the melted rock solidified relatively quickly, creating a solid plug that sealed off the magma chamber. However, this solidified plug was not uniform and contained numerous cracks and crevices. Over time, water from the ocean seeped into these cracks, reacting with the hot rock and creating vast amounts of steam. The pressure from the steam caused the rock to fracture, and the molten rock escaped, leading to the formation of new magma chambers. And if you think that's a wild theory, just consider the fact that it's already been observed in other places where asteroids have impacted Earth. For example, in the Poppyguy crater in Siberia, Scientists have found evidence that an asteroid impact created a magma chamber that later erupted, leaving behind a layer of ash that may have contributed to the extinction of dinosaurs in the area. But it wasn't just the asteroid impact that could have led to the formation of supervolcanoes. There's also evidence that suggests the non-impact effects of the Chixulub event may have played a role as well. You see, one of the most significant consequences of the asteroid impact was the massive amount of sulfur compounds released into the atmosphere. These compounds formed sulfuric acid, which reflected sunlight and cooled the planet. The temperature dropped by an estimated 5 to 10 degrees Celsius within a few months. However, as the dust settled and the sun began to shine through once again, the remaining sulfuric acid in the atmosphere absorbed the sunlight and heated the lower stratosphere. This created a layer of warm air above a layer of cool air, forming a temperature inversion that trapped heat near the surface. This effect may have led to a significant increase in global temperatures, triggering volcanic activity in some areas. Take, for example, the Deccan Traps in India. This region contains a flood basalt province that erupted between 66 and 68 million years ago. These eruptions released vast amounts of carbon dioxide and other greenhouse gases into the atmosphere, possibly contributing to global warming. Some researchers believe that the Deccan Traps eruptions may have even triggered the Cretaceous-Paleogene extinction event itself. And while there's debate over whether the Deccan Traps eruptions came before or after the asteroid impact, there's no doubt that they played a significant role in shaping the planet's environment. It's important to note that the asteroid impact and subsequent volcanic activity did not happen uniformly across the globe. Different regions experienced varying degrees of impact and recovery. For instance, the Yucatan Peninsula, where the asteroid struck, experienced some of the most intense effects, including a massive release of heat and light. On the other hand, some areas like the Caribbean may have experienced only minor effects from the impact, but significant melting due to the shock wave. In contrast, regions like Antarctica saw a rapid increase in volcanic activity after the asteroid impact, likely due to the release of carbon dioxide and other greenhouse gases. These gases may have warmed the climate, triggering the melting of ice sheets and the release of water vapor from the oceans. The water vapor may have further warmed the climate and contributed to more volcanic activity, creating a positive feedback loop. On the other hand, regions like Europe and Western Asia experienced relatively low levels of volcanic activity after the asteroid impact. This may be due to the orientation of these regions relative to the asteroid impact. Since the asteroid struck the Yucatan Peninsula in Mexico, the western United States, Europe, and Western Asia were located in the shadow of the Earth during the impact. This means that these regions received less direct sunlight during the impact and were likely less affected by the initial heat and light. Additionally, these regions may have been shielded from some of the debris and ash that was released into the atmosphere, which could have blocked sunlight and cooled the planet. As a result, the volcanic activity in these regions may have been relatively low compared to other parts of the world. But why does any of this matter? Why should we care about a bunch of ancient volcanic eruptions? Well, believe it or not, there's a surprising amount of evidence to suggest that these very same volcanoes may hold the key to understanding why life kept going after the asteroid impact. For example, in the Lacustrine Basin in Western Canada, scientists have found fossils of turtles that survived the asteroid impact. These fossils suggest that some species were able to survive the impact and the subsequent environmental changes, and surprisingly, the turtle population rebounded quickly. In fact, within 1 million years after the impact, there was already a wide variety of turtles living in the area. And while you might be thinking, yeah, but turtles are kind of like cockroaches, they're hard to kill. Keep in mind that other species like the dinosaurs weren't so lucky. So, what made the turtles so resilient? Well, some researchers believe that the key to their survival may lie in the volcanic activity that followed the asteroid impact. You see, the Lacustrine Basin is located near the Yellowstone supervolcano. And while the Yellowstone supervolcano didn't erupt during the asteroid event, its presence may have provided an unexpected benefit for the turtles. Prior to the asteroid impact, the Yellowstone supervolcano had been dormant for millions of years, but the impact may have triggered a surge of geothermal activity, providing a refuge for organisms like the turtles. In fact, studies of the sediments in the lacustrine basin show that there was an increase in volcanic activity following the asteroid impact. This suggests that the asteroid impact may have reactivated the Yellowstone supervolcano, creating a warm microclimate that provided a safe haven for the turtles. And if that sounds crazy, just consider the fact that the Yellowstone supervolcano is still active today. It's one of the most powerful volcanoes in the world, and it's located in an area that's home to a wide variety of wildlife. The volcano provides a unique habitat that supports a variety of plants and animals that are adapted to the geothermal activity. These include species such as the yellow-bellied marmot, which is a large rodent that's found only in the Yellowstone supervolcano area. So it's not far-fetched to think that a supervolcano could provide a unique habitat that helps organisms survive an ecological disaster. Of course, we can't say for sure what role the Yellowstone supervolcano played in the survival of the turtles. But the evidence is intriguing, and it suggests that volcanic activity may have had a significant impact on the recovery of life after the asteroid impact. After all, the asteroid impact and subsequent volcanic activity may have created a domino effect that led to significant changes in the environment. These changes may have paved the way for new species to thrive and eventually dominate the planet. So while the asteroid impact was undoubtedly a catastrophic event, it may have also set the stage for the rise of new life. And that's pretty wild to think about. Now I want to hear from you. What do you think about this new evidence linking asteroid impacts to supervolcanoes? And do you find it fascinating or terrifying? Either way, I'd love to hear your thoughts in the comments below. Also, don't forget to subscribe if you want to learn more about amazing discoveries and scientific breakthroughs. Thanks for watching, and I'll see you next time.